Hello, everyone. My name is Johan. This is for my Duke COMPSCI 372 final project, and I work this project alongside Calvin, who is my partner for this project. And our project name is a classical music generation model, and this is for the demo video. So, first, I would just want to go through like briefly just like our motivation on this project. So, we just hope that for this project, like it could positively impact society just by making music creation accessible to people who may not have formal training or access to traditional composition tools. So, we hope by like, just giving students music hobbyists or even musicians we want to give them an easy way to like explore musical ideas and learn through experimentation. And so by combining machine learning with a simple web interface that we have built, and we just hope that the project encourages creativity, be able to support education, allow more people to engage with music in a new and meaningful way. And then I will say that our project, we focus on classical era composers. So, and we train our models using we trained on Haydn, Mozart, and Beethoven to keep a consistent tonal style. And with that, we just hope that the browser app that we built just let the users like and use these models to like generate MIDI files without any deep and technical and music theory expertise. And with that app, I will say that we built a transformer model that is able to produce musical token sequences and a diffusion model that is able to generate piano roll images. And with both of these models, like able to output and convert back to like MIDI files for like playback, able to play stop music. And we just hope that users can generate new pieces. It would preview them in the browser and view like the piano roll images and download the MIDI files, as well as using our feature that we built for using OpenAI Assistant Helper for generating prompts. So let's just begin with the showing the actual web app. So yeah, so this is our web app. As I mentioned from I briefly walked through the technical video. Is also through the repo how to set up the environment and run the app. So we divide into three interface: the transformer, diffusion, and about interface. So this is the about page. So it's just being talk about the purpose of this project, where we got the data from, and talk briefly about our transformer models and our diffusion models. And then here is our transformer models here. So we have our own customized transformer model that we built, and we also have a fine-tuned GPT-2 model. With our own transformer, wait to start here. It is unlimited like use of tokens, so it could be like 1,000, 2,000, and such. But with the GPT-2 fine-tuned, as mentioned here, it only has a limit of 1,024 tokens and us to actually run this. So we have a starting template here. So you use the default link, height, and motor. So let's start with here. Even able to change like the token input here too. Let's start with B. Able to generate the MIDI. It could take like typically take like a few seconds, maybe even a minute to generate the music. But once it does, it should display like the playback feature, and you'll be able to download the MIDI files. Here, it could take a while. I see here. With the playback feature, you're able to play, you're able to stop. Here you go. Even it has to generate like token sequence that our transformer model that built, able to download the MIDI file. And with our customized transformers, like the output could be inconsistent, but it's still fun to like listen to. And then let's try to use the GPT-2 model. Here with the AR prompting, you can um type what you want your music to be. So let's just use this up here fast. With a major whatever. Able to drop the token here using the OpenAI model. Then here you're able to paste it to the main input. And we see here, and then you can generate the MIDI file here. And I will say with the GPT-2 model, most of like the outputs, they're more consistent. So yeah, but generate good music too, I would say. See here. Yeah. Sounds pretty good. Again, able to see like the generate token sequence that this fine-tuned GP2 models have generated, and you're able to download the MIDI file here. And as for our diffusion model, um, we divide to like a conditional model, which just generate a random piano roll image, and conditional model, which will generate image based on your style, which I'm going to show you soon. And here's the unconditional. It takes like again a few seconds, maybe a minute, to generate the image here. And then below it will show you the generated like piano roll image, and then you would place the notes and see that image here. Able to download the MIDI file, and then here's something conditional where you're able to select your what composer you want, and the while to generate. So let's use Beethoven, and then you're able to select the keys, the D, the BPM, and then here you're able to use the guide scale. So let's start here, and then generate here. Once it generated, it should display the image below. And give it a second here, and then it should generate the image and you place the notes. Yeah, and then you can play. Yeah, and what I like about like all the features that we built is that it's just fun to like just experiment and play around with. So yeah, again here, like you're just able to see if you like whatever the music had generated, you can able to download it. Which is neat. And me and my partner we have a fun time generating different music. I see it here. So yeah, it's just fun to see what our mods have generated. But with that, that's it for our demo video. So thank you all for listening.